Solving radical equations and equations with fractional exponents is what we're going to look at today. Solving so we'll start with just the radical equations. Example 1, 2 times the square root of x plus 2 equals 8. Now these equations have extraneous solutions because our square root cannot be negative. So we have to make sure we check our answers in the end to make sure that we find the extraneous solutions. When there's an even root, we have extraneous solutions. When it's odd, we do not. So in this equation, I want to get my square root by itself. So I'll divide by 2. I get the square root of x plus 2 equals 4. And to get rid of the square root, I'm going to do the opposite, the inverse, which is to square both sides. So we get x plus 2 equals 16. And subtract 2. And we get x equals 14. And we'll check for extraneous by plugging it in. 14 plus 2 equals 8. 2 times the square root of 16 equals 8. And 2 times 4, oops, I wrote 8, said 2. 2 times 4 equals 8, so it checks. So our answer is x equals 14. How about a cube root equation? We have the cube root of 2x minus 9 minus 1 equals 2. Now the minus 9 is under the radical. This minus 9 is under the radical. The minus 1 out here is not. So we will need to get rid of this minus 1 first and move it to the other side. So we're going to add 1 to both sides. We get the cube root of 2x minus 9 equals 3. To undo the cube root, we cube both sides. And we get 2x minus 9 equals 27. And then we've solved the two-step equation. Add 9. 2x equals 36. Divide by 2. And x equals 18. Now, extraneous solutions aren't really an issue with the cube roots because the cube root is allowed to be negative underneath, because negative powers end up negative. Odd powers end up negative. But if we plug this in real quick just to make sure we did everything right, we should get 2 times 18 minus 9. That's a cube root of minus 9. 36 minus 9, cube root of 27. And then minus 1 should equal 2. That's 3 minus 1 equals 2, and it checks. So we did the problem correctly. Now, sometimes we have equations with variables on both sides. So we have x plus 1 equals the square root of 7x plus 15. Example 3. When this happens, this is where we really end up getting extraneous solutions because we're turning it from a square root equation into a quadratic. When we do this, we need to get rid of this square root, so we're going to square both sides, and when we square x plus 1, remember that's x plus 1 times x plus 1, you have to FOIL that out, right? X squared plus x plus, I don't know what happened there, x squared plus the x plus this x plus 1, and then I get x squared plus 2x plus 1 on the left side, and on the right I get 7x plus 15. And now I have a quadratic, so I need to move everything to one side. Minus 7x minus 15. So x squared minus 5x minus 14 equals 0. And my first method of solving this would be to factor. What two numbers multiply to negative 14 and add to negative 5? Let's see, x minus 7 and x plus 2. So that means x equals positive 7 and negative 2. So which of these are going to work? Because remember, the square root cannot equal a negative either. So if I plug in 7, I get 7 plus 1 equals the square root of 7 times 7 plus 15. That's 8 equals the square root of 49 plus 15. And 8 equals the square root of 64, which is true. But when I plug in negative 2, I have right here the fact that negative 1 equals the square root of negative 14 plus 15, which is not going to be true because I can't have the square root equal a negative, and I can't take the square root. Here I end up with negative 1 equals 1. This is not true. So negative 2 is extraneous. So my solution is x equals 7. And we only list the one that is correct. That's not extraneous. What if we have roots on both sides? Example 4. Square root of x plus 2 plus 1 outside the radical equals the square root of 3 minus x. These ones get a little tricky. This 1 here is going to have to be treated like a binomial, and we're going to have to FOIL when we look at this side. In order to get rid of the square on this side, or the square root, we're going to square both sides. But when I square the square root of x plus 2 plus 1, I have to remember that that is the square root of x plus 2, let me shorten that, plus 1 times the square root of x plus 2 plus 1. And you know how I like my vertical multiplication. So we're going to multiply these together. And I get 1 times 1, right? 1 times 1 is 1. Then I get 1 times the square root of x plus 2. So square root of x plus 2. Just keep doing that. And then square root of x plus 2 times 1, that's this. This times this. That's another square root of x plus 2. That's a plus 1. And then the square root of x plus 2 times the square root of x plus 2 is x plus 2. X plus 2. I could put the 2 over here. I could put it over here as well. Let's do that, just for space. So when I add these together, I have 2 square roots of x plus 2 plus x plus 3, and that equals 3 minus x. So then we're going to move everything to the other side, and we get minus 3 and minus x. So we have 2 square root of x plus 2 equals 3 minus 3 is 0, negative 2x. Then we can get the square root by itself, divide by 2, and I'm coming up to the other side. Square root of x plus 2 equals negative x. And then we have to square it again to get rid of that square root. So now we can get rid of this square root, and we get x plus 2 equals x squared, and minus the x and minus the 2. So we have x squared minus x minus 2 equals 0. And that's going to factor to x minus 2. Oops, put another x in there. Minus 2 and x plus 1. So x equals 2 and negative 1. So you can see these ones are a little bit more complicated. This is the part here where you really have to pay attention to. Be careful when you're multiplying out that binomial. And then we still have to check extraneous. So when I go back, let's see, we plug in 2, so I get the square root of 2 plus 2. That's a little big. Plus 1 equals the square root of 3 minus 2. So that's square root of 4 plus 1. That's 2 plus 1 is equal to the square root of 1, which is not true. 3 does not equal 1. So 2 did not work. Let's try negative 1. Let's move this up and have some space here. The square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. And that's the square root of 1 plus 1 equals the square root of minus and negative becomes plus, so 3 plus 1 is 4. So that's 1 plus 1 equals 2. The square root of 4 is 2, so that is true. So don't get tricked into thinking that the negative is always going to be the extraneous answer. In this case, the extraneous was actually the positive 2, and the one that actually works is negative 1. So your solution is x equals negative 1. So make sure you check for extraneous. Don't just assume that the negative solutions are extraneous. Now, what if we have a rational exponents? So, for example, we have 2x to the 3/4 power plus 2 equals 10. So we're going to solve this by getting the exponential function part of it by itself. So we're going to subtract 2, and I get 2x to the 3/4 power equals 8. Now, when I have a fractional exponent, I want to make sure the exponent becomes 1. So I want to take something, 2x to the 3/4, and I want to raise it to a power so that the exponents, when I multiply, equal 1. And what fraction, 3/4 times the reciprocal, 4/3, will equal 1. 12 over 12, or the 4 and the 3 cancel and give us 1. So when I have fractional exponents, I'm going to raise it to the reciprocal power. So for this problem, I'm going to raise it to the 4/3 power. So 8 to the 4/3 power. I get 2x because my exponent becomes 1 equals, and 8 to the 4/3 is the cube root of 8 to the 4th power. The cube root of 8 is 2, and 2 to the 4th is 16. So I get 2x equals 16, divided by 2, and x is equal to 8. And I can look at that again, make sure it's not extraneous. Remember that 3/4 power is really the 4th root of 2x cubed. That's what this is. So I have to pay attention to the fact that if it's an even denominator, I can't have a negative inside the radical. So if you get a negative answer, you need to check for extraneous, especially on these ones. So let's see if 8 works. 2 times 8 to the 3/4 power, is that equal, or plus 2, is that equal to 10? I get 16 to the 3/4 power. The 4th root of 16 is 2. 2 cubed is 8, plus the 2 is equal to 10, and that checks out. So your answer is x plus 8. Let's look at another one. X plus 30 to the 1/2 power equals x. So we get the opposite. The reciprocal of the 1/2 power is the square. Remember that 1/2 power is the square root of x, so it would make sense that the squaring both sides is the reciprocal, the inverse function. So remember reciprocal, 1/2, I don't want to raise it to the 1/2 power. That's going to give me 1/4, not 1. So when I square both sides, the 2 and the 1/2 equal 1, so I get x plus 30 equals x squared, and then I can subtract the x and subtract the 30. So minus the x minus the 30, 0 equals x squared minus x minus 30. So you can see your factoring skills once again are going to come back, and you need to be able to factor, especially your simple trinomials. So what two numbers multiply to negative 30 and add to negative 1? X minus 6 and x plus 5. That makes x equal to 6 and negative 5. So now we're going to have to check for extraneous again. 6 plus 30 to the 1/2 power equals 6. That's 36 to the 1/2 equals 6, which is correct. Then I have negative 5 plus 30 to the 1/2 power equals negative 5. That's 25 to the 1/2 equals negative 5. 25 to the 1/2 is a positive 5. So negative 5 doesn't work because it doesn't equal the negative. So x equals 6 is our only answer. Negative 5 is extraneous.